In this example, I need to verify the following identity, where I have 1 minus sine theta all divided by 1 plus sine theta equals the quantity secant theta minus tangent theta all squared. When working with identities, we always want to start with the more complicated of the two sides. Both of these look fairly complicated, but if I started working with the left-hand side, what would be the first thing I do? I'm not sure. But if I work on the right-hand side, there are some obvious steps that we can take. So I think I'm going to start working on the right-hand side. So here is my right-hand side. Now, I could start off by squaring this binomial. But looking at what I want to prove, notice there's only the sine function on the left-hand side. So I think before I do any squaring, I am going to write everything on the right-hand side in terms of sines and cosines. So I'm going to need a couple of identities. I'm going to need the tangent and the secant written in terms of sines and cosines. So I'm going to have, instead of secant theta, I'm going to have 1 over cosine theta. Minus tangent theta will become sine theta over cosine theta. And then I'm going to have to take that binomial and square it. But if you notice, something very nice happens. I already have a common denominator of cosine theta. So I can write this as 1 minus sine theta all divided by cosine theta all squared. Now I'm going to square my numerator, so I'm going to have 1 minus sine theta all squared divided by cosine theta all squared, which is cosine squared theta. Now, before you're tempted to expand this numerator by multiplying 1 minus sine theta times itself, look at what you're trying to prove. I need to have a 1 minus sine theta left in my numerator. I have 2 right now, so I definitely don't want to expand this. Looking at what we want in the denominator, the only trig function there is sine. But I have cosine in this denominator. So how are we going to get rid of this cosine squared theta? Well, hopefully you remember the most important Pythagorean identity, which says sine squared x plus cosine squared x equals 1. So cosine squared x is going to equal 1 minus sine squared x. So over here, I'm going to leave my numerator alone, 1 minus sine theta all squared, divided by, instead of cosine squared theta, I'm going to have 1 minus sine squared theta. So this is looking very promising. What I'm going to do is I'm going to write my numerator out as 1 minus sine theta times 1 minus sine theta. And then your denominator, 1 minus sine squared theta, this is the difference of 2 squares. So I can factor it. So the first term in both of these parentheses is the square root of 1, which is 1. You're going to have opposite signs in your parentheses, and the square root of sine squared theta is just sine theta. So my denominator factors into 1 plus sine theta times 1 minus sine theta. Then something very nice happens. One of the 1 minus sine thetas in the numerator reduces with the one in the denominator, and you get left with 1 minus sine theta divided by 1 plus sine theta. And that is your left-hand side. So you've shown that the right-hand side equals the left-hand side, so we have verified this identity.